MIT, for us, the internship is the first time. You accepted the internship, and the first time you told me that they had the satisfactory some performance and result. We are very happy, and we are very eager to have next the internship as well. So a lot of the students, graduate students in Korea, are very interested in this program.
Ah, great.
Yeah. So
you keep sending me great students. That's good. So
the Korean students were very eager to participate in your intern program, which is highly competitive with many applicants in Korea. And would you please briefly describe a set of features of your intern program?
yeah, so I mean, what we did is they were able to get access to equipment that's really state-of-the-art kind of equipment. But the kind of stuff I do in my lab is also very fundamental, very first principles, right? So it's first principle modeling, control, optimization, design, right? It's really, and many people that are trained in that, it's called process system engineering, they only learn the algorithms. And usually they learn one algorithm, right? And part of one algorithm, right? But in my group, we work very closely with real equipment, right? Usually on processes either I design or other people I collaborate with design. And so then it's, what's nice about that is that if you take a field like distillation or crystallization, if you just do just that aspect alone, then the processes are known. I mean, the equations are known. There's procedures. You follow the procedures you design. But a lot of the stuff we work on here at MIT is we invent new processes, right? So you'll invent a process that may be adapted from somewhere, but not really for the purpose. You follow, like the injection molding example, right? Injection molding certainly exists, but not for drugs. And with drugs, you have to be careful because you have to be careful about the temperature profiles and how you manage that, because if you don't, you create impurities, which you don't care about in a model car part. But you definitely do care about if people can eat it, right? Consume it, right? So, and then the properties are quite a bit different. You're sort of in a different part of the phase diagram, right? So you get different types of polymer properties and so forth. So, and so those are examples where we also do here, we invent crystallizers, that look different. So if you look at our crystallizers, they're described by different equations than what you would normally see in literature. And so then we'll say, okay, how do you go about doing chemical engineering on this new process? You follow? And we do like ultrasound, and, different kinds of inputs you normally don't see in a chemical process we'll have in our processes, right? And so it's actually, it's a different thing that you don't get a lot of people working on. You do get experimentalists who might be doing ultrasound, but then they won't build the models, right? They won't do the process system engineering part. They'll only do the experiments. They'll do experiments, say, here's what I get. And then they publish in experimental journals, right? But in our case, we'll actually do the modeling, do the design, do the control, right? We do the PSE, the process system engineering.
So it sounds like your approach. And once your approach is in between between the commercial stage and experimental stage, and then your modeling for new process, it's gonna have a big contribution to make a commercial
that's the
process system.
So what we do is we invent things with collaborators, then we develop the PSE, and that's the technology so that somebody else can apply it to do process development, for example, develop process. And then some of those we invent, nobody will probably ever pick up for whatever reason. But some will be successful, right? And those ones that are successful, then those go out there and make an impact. You follow? Because, whenever you're inventing processes, you have a lot of good ideas, and some things work like really great, and then some things don't work quite as great, right? So, but the overall approach we use is very consistent, though. So all the different processes, I have a certain way of doing PSE, and I do that same kind of approach. So anyone who reads my papers can still learn about the way we tackle problems, right? You see what I mean?
Yeah.
Even though, like the way we do MPC, for model predictive control, for example.
Oh.
Right, so we have very special ways of doing model predictive control that are not what most people would be working on. And they wouldn't look at it the same way we work, so they look at different kind of problems, right? We look at very specific kinds of problems. Does that make sense?
Yeah, I get some pharma or the related the industry should have been interested in your research.
That's who funds our research. Yeah, sure.
Yeah.
Of course.
So,
over half my funding comes from companies, right? They're basically high-tech companies that are interested in new technology, that allows them to do things. Usually cheaper, but they're not really focused on cheaper. It's usually to give an extra product quality. It's more about extra performance or extra control. Because that's worth more really than lowering cost. Even though it also lowers cost, but that's not really the driver. It's really giving new features, right, or better quality, right? So those are the kinds of things that I work on, right? And so that's pretty much consistent. So I get a lot of company funding. I get probably half, or sometimes more than half. So half to more than half is actually from companies. High-tech companies.
And the other parts come from
will be
the government?
foundation. So like Gates Foundation, I get funding. In that case, they actually do care about cost mostly. Try to have vaccines that are really cheap so that it can basically vaccinate all of Africa, for example. So that case actually is based on cost, but it's still driven by inventing processes, invent new processes, right? So it's related to, and because you're related to quality or cost, you need process engineering, right? So that's why we do that part. And then we have DARPA, and then occasionally NSF and NIH. So usually the stuff I do is, so we develop technology. Our goal, we'll demonstrate it, like in our lab or with collaborators. But then once we've demonstrated it, then it's the technology that's the product.
Okay.
You follow? Then somebody else can pick that up and do it. Okay. So in that case, we're not really applications. You see what I mean? I mean, we develop a technology and a process and invention, but then that's supposed to go to other people to apply it. Does that make sense?
Yeah.
We demonstrate it once to show that it works.
Just the curiosity. If the students, the applicants from Korea apply, and then what do you think? Is willing to consider the admission?
Well, no, of course, right? So yeah, the number 2 foreign applications is actually 3. The top 3 are China, India, and Korea, right? So those are the 3. So if you look at the international students, we get them from around the world.
Sure.
But those 3 would have the largest percentages, right? Would be those 3 countries, yeah.
So how are the Korean interns done as compared to your students in terms of attitude, approach to the problem solving and performance? I think this is what you already said, but just briefly.
The students were quite independent. So once they were sort of defined the overall level of project and what to do, they drove hard onto doing that. So they worked hard and they worked smart because I got students that were already very well trained. They weren't beginning graduate students, right? They were already, and then they, like for example, they already knew computational fluid dynamics. They already knew how to run Fluent. So they could do it very fast, right? Because they already had the right kind of skills.
Okay.
So that helped a lot. So.
Okay. And the last, for future Korean interns, is there anything that you would like to say, emphasize, or recommend so that they will get your internship successful as a win-win relationship?
Well, it's always 2 things, right?
sustainable.
It's always skills, high skills. So learn high skills. And work hard. That's the key to everything, right?